Okay, in this short video we're going to show you how to use a potentiometer. So we're just going to do a simple DC circuit here. Now you could use these potentiometers obviously in more complicated circuits. So I'm just going to do a 10 volt power supply here, and then I'm going to do analog and just do a resistor. And then I'm going to go into the breakout library. So the breakout library is where the pot is. And you definitely want to use that particular one there. And I'm just going to leave those values as is, 1K and 1K. And then, since I'm going to use this as a variable resistor in this example, I'm just going to tie two terminals together. But in general, you might use all three terminals of an op-amp. But since I'm purely using it as a variable resistor, you tie two of the terminals together, because then basically you can use this potentiometer as a way to vary from 0 to 1K. Now some people say, oh, you can just leave the other terminal open and no connections. I was always taught that it's better to tie two of them together so that there's no accidental chance of shorting it or grounding it or something of that nature. So that's the way I was taught to always do it. So now what we're going to do here is we're going to just go ahead and simulate this as is and see what happens here. So we're just going to do transient for this. There's not really a lot to do in this particular simulation. I'm not going to have to worry about how long to set it. Now, if you're doing it with like an op-amp where you have a signal present, you might have to determine what the frequency is in order to run the transient response long enough. In other words, if you're using a particular frequency of a signal, here you would want to change your runtime. But since I'm just doing DC here, I don't really need to worry about that. So I'll just hit OK, and then I'll just run the simulation here. And we patiently wait for the simulation to run. Communicating with server. Alright. Okay, so it's done simulating. Now, because I'm not doing any kind of AC circuit or anything, I'm just going to look at the voltages here. So we can see that there is 10 volts here, and then this is 3.3 volts. But basically at 0.5, that means this is 0.5 of 1 kilo ohm. Now you have to be careful. Sometimes, depending on how you short these together, when we go to different ones here, we'll show you in a second what I mean. And so basically it's just a 500 ohm resistor, 1 kilo ohm. Simple voltage division would say that's a third of your power supply. So that's why it's 3.33 volts. But now let's change this to 0.8, for instance, and let's rerun it again. Now the voltage has increased to about 4.44. And again, if you want to think about what the resistance here would be, it'd be 1K times 0.8. So that resistance here is 800 ohms. Now, you do have to be careful on how you put these together. And what do I mean by that? If you look here, see how that says number 3, number 1, and number 2 when you click on these pins of this potentiometer? You want to make sure 1 and 2, if you're using it as a variable resistor, you want to make sure 1 and 2 are shorted together to be used. So that way this set is equal to 0.8 will give you 1K times 0.8 being 800 ohms. Now, if I wanted to, for instance, change this to 0.2, I would just then rerun the simulation again, and again the voltage is going to change because now I have a 200 ohm resistor here instead. So that's how you use these potentiometers. Now again, you don't always have to have them tied together like this. In other cases, in some of the other labs we're going to be doing, we won't have these terminals tied together. We'll actually be using it as a potentiometer. Now when you wire this up in a circuit, Technically, it doesn't matter which terminal you short together versus which one you don't, but it will determine whether you turn something clockwise and increase the resistance, or whether you turn it counterclockwise and increase the resistance. That is going to be determined by which leads you have shorted together.